All right, this is section 7.18, linear and nonlinear function distinction. And it's almost the last section in the chapter. It goes to 7.18, and we're almost to the end. Now, what we're going to be looking at is, we talked about linear functions. And these have a straight line, right? Now, a function does not need to have a straight line, only a linear function. We have nonlinear functions. And they don't have to be straight. They can be curved and bent. Let's take a look at some quick examples. Now, if you'll notice, I am doing my notes on graph paper. You don't have to, but I find that we're going to be doing some graphing in this section, so I kind of just skipped right to it and put this paper instead. So if I drew some quick rough coordinate planes, now I'm not going to be adding in my numbers here, but it's going to be the shape of the graphs that matter. And I'll label my X and Y, just so that I can make sure to remember. The graphs that we've been looking at so far often kind of look like this. They have a line somewhere on our coordinate plane. And often they're going through points as they go. And those are the points that we kind of determined and that we graphed. However, and this is a function, it passes the function test. And one of the function tests I can do is, say I had a pencil, I can follow it and I never have to pick up my pencil. So I know that it is a function because there's never two outputs for one input. Because otherwise, if I went here, there would be like a line here and a line here, and that couldn't be. So this is a function, and it's a linear function because it has a straight line. However, occasionally I will be graphing a function, and I may put points like this. And this function would look like this. Ooh, I made it a little bit long, kind of went crazy there. And you'll notice immediately that this function is not a straight line at all, in fact. It is clearly bent, and then sometimes you'll even see functions that look like this. This one is even more so. It will often kind of look like this, taps the origin, and then goes back up. This is clearly not a straight line, but it is still a function. So we're going to be talking about the differences between these, and you're going to be doing some graphing. Now, we're going to be taking a look at this fairly famous nonlinear function, and we're going to build an output table for it. Now, my little line went down a little bit lower, so I'll hang on. Oh, that's okay. Let's build the input-output table, and remember, I'm just going to use the X and the Y instead. X and Y. And the rules, the numbers that I'm going to check out and try, let's do -2, -1, 0, 1, and 2. And the rule that we're going to use for this table is y equals x squared. Now, if you recall what x squared means, that does not mean x times 2. Remember, that's very different. This means x times x. And that's very important for our rules and for looking at how this graph turns out. So, let's do a little bit of building and see how this goes. First, let's finish our input-output table. Okay, -2 squared. Well, that would be -2 times -2. And a negative times a negative is a positive. And 2 times 2 is 4. So my answer in this case is going to be 4. Because I did -2 times -2. Okay, -1 times -1. Well, 1 times 1 is 1. -1 times -1. And a negative times a negative is a positive. I have a 0 here. 0 times 0 is 0. 1 times 1, well, I guess I can write my 0 times 0. 1 times 1 is going to be a 1. And 2 times 2 is going to be 4. Some alarm bells might be going off. How can I have 4s on both sides and 1s on both sides? Remember, the only rule is that a -2 has to lead to the same number. I can certainly have doubles on this other side, and that's okay for it to be a function. Okay, now let's do some quick graphing. Let's see. Let's see. Oh, I need to go from -2. I have -1, -2, -3. You guys can see this. 1, 2, 3. I have to go up to 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm actually going to go to 9 for a reason you'll see in a second. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm just going to go by 2s. 2, 4, 6, 8. -2, -4, -6, -8. And the reason I went by 2s is I'm going to actually add 2 more numbers to this chart once we get going. Okay, my first number is a -2, 4. 1, 2, up to 4. Right there. My second number, -1, 1. -1, 1. My third number, I've got the origin, or 0, 0. My third set, 1, 1, 1, 1, right here. And my fourth set, 2, 4. Interesting. So you can kind of see how that looks. Let's do... Oh, I guess I didn't need to go so low. I don't know what I was thinking. Let's take a look at if we add in 2 additional sets. Let's go to 3, and let's put in -3. So 3 would be 3 times 3. Which is 9. And -3 would be -3 times -3, which is also 9. So if I'm going to add these in, my 3, 9, 1, 2, 3, is going to be all the way up here on my old graph. Sorry, I'd kind of cluttered. I should have probably used a separate page. And my -3, 9, 1, 2, 3, it's going to go all the way up here as well. Now, if I'm going to connect all of these dots, it's going to look like this. Hopefully I'll be able to do it okay. And I can immediately see that this is definitely not a linear function. It is a nonlinear function. And the key is, you can see this is going to be a nonlinear function whenever you have this little exponent anywhere. That's going to be a big clue that this is not going to be a straight line. And that is going to be the key focus. Now, for the homework, it looks like you're going to mostly be identifying linear and nonlinear functions. You're also going to be creating some tables, and you should be able to figure out all of these questions based on the little graph that we've done. You're going to need to do a little bit of work in figuring things out, but I think you should be all right. All right. Good luck.